So in order to combine what we learned in last lesson on frequency tables and graphs and what we learned today on quartiles, we can develop and graph out cumulative frequency graphs. These illustrate percentiles. Since quartiles mean quarter, right? So it's every 25%. Median is 50%, lower quartile is 25%, and upper quartile is 75%. So going up by 25% each time. Through these quartiles, they can help us define percentiles on our frequency graphs. Today we're not looking at just frequency, we're looking at cumulative frequency. Here are the results for 2008 Olympics women's marathon records. So here we have finishing times and frequency. Finishing times, as you can see, are ranges. This tells us that this is continuous data and not what? Discrete. Exactly. On the left hand, the smaller value of the range, you see how it's less than or equal to the t, whereas there is no equal to the larger side of the range. This is because, remember, that way we can have overlapping columns so that they touch each other, and when we graph it out, it would look like a histogram and not a column graph with gaps. Because this is cumulative frequency graph, what we did last time was we would probably, with a range, with a continuous data, we would find the midpoint, right? And then we would multiply it by frequency f to find the product. But today we're not doing that. Because it's cumulative frequency, we need to find the cumulative of each of the frequency values. So we're going to start with the cumulative results. The first row is 8. Because it's cumulative, the second row, you would have to add the first row. You would add the earlier times, so the times of women that finish running earlier than the second column of women, and you would keep adding them up. So by the last row, this tells us that there is a total of 69 Olympics women marathon runners. So of the 69, we can then graph out the cumulative frequencies based on the finishing times. So cumulative frequency would be on your y-axis, your finishing times on your x, and you would easily be able to label out these ranges. Here we use dots as opposed to columns. That's because this is easier for us to locate the quartiles later on. As you can see, the maximum number of women that can participate in this marathon is 69, right? So we're assuming 69 equals to 100%. So median means the middle number. 69 is an odd number, so we can essentially just divide that by 2 and figure out the middle number, which is what? 34.5, around that. So as you can see, do you see that the median, if we trace upwards, that's around 34.5, so around 35 at the cumulative frequency. Because, as you can see here, this would tell us the lower quartile, right? Lower quartile just means the first 25% of the total 100. So you could just use 69, which is our cumulative frequency, the maximum 100. So we have 69 females. If we want to find the first 25% of females that finish running, then we would just multiply 69 by 0.25, and this would give us the value of cumulative frequency for the lower quartile. We would do the same thing for the upper quartile, multiply 69, and set upper quartile is what? Q3, right? And that is 75%. So we multiply 69 by 0.75, and this gives us the upper quartile, which is around 52. I think it was 51.75, I think. And that rounds up to 52. An easier way for us to see the quartiles, so the percentiles, better in cumulative frequency graphs, these typically are graphs that tell us around what percentage of people or certain data sets fall within the top 25% or the top 50% or the top 75 or the entirety, right? So that's why all of these cumulative frequency graphs are going to go up. The trend is going to look like it's going upwards. Cumulative frequency graph could also be represented with two y-axes. So your left one would be your usual cumulative frequency axes, but your right one would be the percentiles. So percentiles, assuming that your maximum, this is just a data set where it's out of 240. 240, assuming that this is 100%, right? Then half of 240 is what? 240 divided by 2, that's 50%, and that's 120. So we find 120, and we find the intersection with our line. And then we go downwards, and we find that this is Q2, right? Q2 is the median, the middle number. So its middle is 50%. So that's Q2. Q1 would just be the 25% of 240. So 0.25 multiplied by 240. That gives us 60. That's Q1. And then we have Q3, which is the upper quartile, 240 times 0.75, 180, intersection. Once it crosses, go downwards, and we find Q3. And this happens, the x-axis happens to be a score. So you're comparing scores with the cumulative frequency of maybe a certain group of people scoring 100%. So on their test or something, right? So this is just an example of how frequency tables and frequency graphs can be combined with percentiles to determine all the different quartiles. And these quartiles are important because once you find these quartiles, you can easily calculate your interquartile ranges, and you can calculate your upper and lower bounds, and you can figure out what is within our upper and lower boundary, our general body of data, and what data points would be outliers.